The culmination of precision engineering, the Centurion system represents the next generation of defense technology for GDS engineering.
Welcome to GDS Engineering. I'm Dr. Stevens, and today we'll show you how we transform raw steel tubes into advanced rocket launcher systems with unparalleled precision.
Inside the DMG Mori, we see the tooling carousel. This machine is capable of micron-level precision, essential for aerospace manufacturing.
The aluminum block is meticulously shaped by the high-speed milling tool, bathed in coolant to ensure a flawless finish. The simulation demonstrates how the robotic arm precisely bends the tube, utilizing controlled magnetic field.
Here we see the macro view of the welding process, where the steel tube begins its transformation.
Precision is paramount. This borescope inspection allows us to examine the critical weld seam, guaranteeing structural integrity for the launcher system.
These steel tubes are the foundation, but they need to withstand extreme pressure. That's where our advanced salt bath nitriding process comes in. The treatment process is critical. We maintain the molten salt bath at precisely 1200 degrees Celsius to ensure the structural integrity of the alloy.
The steel tubes are submerged into the molten salt bath, a critical step in the heat treating process that ensures the strength required for aerospace applications.
The steel tube is submerged into a molten salt bath, a critical heat treatment process that hardens the metal.
This heat treatment process, using a molten salt bath, is crucial for strengthening the steel before it becomes a rocket launcher. Precision is key at this stage. The GDS engineering team uses this rugged tablet to track the heating curve during the salt bath treatment.
The molten salt bath hardens the steel, preparing it for the next stage of precision shaping.
The superheated steel tubes are rapidly cooled in the quenching tank, a critical step for hardening the metal. This intense Submerged in the cooling liquid, the glowing tubes undergo rapid thermal transfer, a precise process essential for achieving the required material strength.
The quenching process is critical for hardening the steel. The tubes are submerged in a
This heat-treated steel tube requires a perfect mirror-like finish for precision. To achieve that, we rely on the Studer S33 behind me.
Utilizing advanced water jet technology, the steel tubing undergoes a rigorous cleaning process, ensuring the highest quality for aerospace applications.
From raw materials to these finished components, every part of the launcher undergoes rigorous inspection before final assembly.
From steel tubes to these advanced rocket launchers, our precision engineering makes the impossible possible.
Utilizing state-of-the-art laser technology, we achieve unparalleled precision, essential for aerospace applications.
Precision-cut square steel tubes are fed into the system, stacking with automated accuracy before moving down the line for the next stage of manufacturing.
Here we see the raw billet of aluminum. Through a complex 5-axis machining process, this will be transformed into the critical fire control housing.
Precision is paramount as the robotic arm secures the aluminum billet within the NTX 2000's chuck for machining.
Precision is paramount. Here, the multi-fluted tool carves the aluminum block, cooled by a high-pressure stream.
This simulation demonstrates the application of localized magnetic fields.
Precision is paramount. Here, the robotic arm executes a perfect seam weld, showcasing the efficiency of our modern production line.
This macro shot highlights the precision of the automated welding process, showcasing the fusion of steel that formed the core of the launch system.
The precision welding process ensures the structural integrity of every component, essential for modern rocketry.
To create the toughest steel for our launchers, we utilize this advanced salt bath nitriding process, enhancing the surface hardness significantly.